Is electricity and magnetism are related? Let us try to understand this by an activity. Here we have taken a cardboard tray. It is wrapped with an electric wire. A small compass needle is placed inside it. The free ends of this wire are connected to an electric cell through a switch as shown. Note the direction in which the compass needle is pointing. Now switch on the circuit and observe the compass needle. We can see that the compass needle deflects. Then switch off the circuit. We can see that compass needle come back to its initial position. Repeat the experiment few times. We know that the needle of a compass is a tiny magnet which points in north-south direction and will affected by any magnetic field around it. In this activity, we have seen that compass needle get deflected when the current flows in a nearby wire. This means that there is a magnetic field created around the compass when current is passing through. So, when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of electric current. Thus, we find that electricity and magnetism are related. Hans Christian Oersted was the first person who noticed the deflection of compass needle every time the current was passed through the wire. So, what are the conclusions of Oersted's experiments? When current was passed through a wire, it behaves like a magnet. The magnitude of magnetic field increases with the intensity of current. Next is about electromagnets. When current flows through a conductor, it behaves as a magnet. Magnet has very important property that it attracts iron. Does the conductor carrying current also attract iron? Let us find out the answer through this activity. Take an insulated wire of about 18 cm long and iron nail, a cell, drawing pin and a switch. Wind the insulated wire around the iron nail, tightly forming a coil. Make a circuit as shown and connect free ends of the wire to the circuit through the switch. Put some pins near the nail. Now turn on the switch so that current flows. As soon as switch is turned on, the iron nail attracts the pins. As a result, the pins stick to the end of the iron nail. However, as soon as you turn off the switch, the current stops and the pins no longer stick to the iron nail. Here the coil behaves as a magnet when current flows through it. However, when current stops, it loses its magnetism. Such coil is called an electromagnet. There are many uses of electromagnets. Cranes that lift heavy loads uses strong electromagnet to do so. With the help of electromagnets, it is possible to separate the magnetic material such as iron from scrap materials. Doctors use tiny electromagnets to take out small pieces of magnetic material that have accidentally fallen in the eye. Many toys also have electromagnets inside them. Next is about electric bell. Most of the bells we see now it are electric bells. Here is the simplest diagram of an electric bell. This is the inner structure of the bell. Let me first tell the names of the basic components. This is the switch we press when we ring the bell. This is the coil of wire wound around the iron piece as well. It will act as an electromagnet when the electric current flows through the circuit. This is a battery and this is a striker or hammer which strikes this gong. That's when we hear the sound. So we can see this is a circuit that can be formed. It is not complete. Why is it not complete? Well, we haven't pressed the switch here. When we push the switch, the circuit gets completed and the current flow was from the positive to the negative terminal. When the current flows through the coil, it becomes an electromagnet. This electromagnet then attracts the soft iron towards it. And in the process, hammer or striker strikes the gong and thus sound is produced. But notice what happens when hammer hits the gong. As soon as the soft iron is shifted away from its original position, the circuit breaks. It no longer connects this wire with the terminal of the battery. And when the circuit breaks, the current stops flowing. So, this electromagnet gets demagnetized after which the soft iron goes back to its start position. This process will continue until the switch is open again. As soon as we off the switch, the circuit breaks and the bell stops ringing. That is the basic idea how an electric bell works. In this part, we have studied about electromagnet, isn't it? Now can you define an electromagnet? A current carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. Electromagnets are used in many devices. You have studied about bar magnet in 6th standard, isn't it? Can you say the difference between a bar magnet and an electromagnet? A bar magnet is a permanent magnet, while electromagnet is a temporary magnet. The strength of bar magnet cannot be changed, but the strength of electromagnet can be changed. The uses of bar magnet are limited, but the uses of electromagnet are more wide. That's all for today's class. Thank you.